Hello everyone, I welcome you to the project on univariate time series analysis. Let's see what does the univariate and time series means. Univariate is nothing but we will be considering only one variable, and time series means sequence of data which is recorded at a given period of time. It can be recorded at daily level, monthly level, or even at yearly level. So univariate time series analysis means we will be analyzing a single variable for the given period of time. So the problem statement is to forecast the sales for an electronics and appliance store for the next 12 months. Before starting with the analysis, let me show you how I have downloaded the dataset. So this is an official website of United States government. So from here I have downloaded the data. So first of all, you can select any data that you want to have from specific industry. After that, you have to select the date range, that is the year intervals from which you want the data. So I have selected the date range from the year 2014 till 2025. After that, you can select any categories from here which are available in that particular survey data or the report data that you have selected at the top. And then these two options I have kept as default. And here comes the part seasonally adjusted and not seasonally adjusted. So there is a difference in these two. I will let you know that difference. So just click on this get data. You will be able to see these two tables. So the first table is about seasonally adjusted sales, monthly sales, and the second table is about not seasonally adjusted sales. So all these numbers or the figures are in the millions of dollars. So what is the difference between the seasonally adjusted data and the not seasonally adjusted data? So seasonally adjusted means some of the adjustments are made to this data, whereas these are not the actual ones. Whereas in the not seasonally adjusted data, there are no adjustment taken. So these are the actual sales. Also, if you focus on this December month, the sales are at its peak as compared to the other months. So these are the real sales, actual values of sales. Whereas in the seasonally adjusted sales, so these are not the actual sales. So they have changed this data, this sales values, and that's why it is adjusted ones. But for this project, we will be using this not seasonally adjusted sales data only. Just click on this link. You will be able to see this CSV file getting downloaded. Open that CSV file. Then you will be able to see that there are two columns available, period and value. So we'll delete the rest of the rows that are not required, and we'll rename this column as date and this column as sales. Now, this data is present in the month and year format. So let's convert it to the date format. So you can do that by pressing Ctrl Shift and down arrow. Press Ctrl 1. Then here in the custom formatting, you have to change it from year, and DD. So it will be in the format like as shown in over here. So let's click on OK and save this file. Also, if you select the sales data, we have sales till the 2025 March only, because as I'm recording this video in the month of April, I do not have access to the sales in the April. That is, we have to forecast. So what we'll do is we'll select this and we'll delete. We'll save this file, we'll rename it, and we will be using it for our analysis. So let's see further steps. So I'm using Google Collaboratory. Here, as a first step, I have imported the required libraries, NumPy, Pandas, and Matplotlib. After that, as the data was present in the CSV format, so I have used the read CSV function from the Pandas and I have stored it into the data frame called as DF. Then to check the first few rows of the data, I have used head function. So head function will give top 5 rows by default. So we have seen that already in the Excel file. After that, to get a quick overview of the dataset, I have used info function. This info function will let us know how many records do we have, how many columns do we have, what are their data types, what is the memory usage, and what are the non-null values present in that particular data. So there are 135 records, 2 columns, Date column is of type object and the cells column is of type integer, and the memory occupied by this particular DF is 2.2 plus KB. There are no null values present in the data. Now, the date column is in object data type, but it should be in the date time data type because we are doing time series analysis, right? So we have to first convert this date from object data type to the date time data type, which can be done with the help of two date time function of pandas. We'll store it back to the date column itself and we'll recheck if the data type for that date column has been updated or not. So you can see that the date column data type has now updated to the date time. Now we have to set this date column as an index of a data frame, as this is univariate analysis and we will be analyzing the cells data. Once you do that with the help of setIndex function, we'll see our DF will look like this. So the index column will be of the date. Then these are the corresponding cells for that particular month, year and day. So we have our data ready with us. Now, before starting with the actual analysis part, we should be familiar with some concepts like what is the trend, what is the seasonality, what is the stationarity, and how can we check its stationarity. So, what is the trend? Trend is nothing but if the values are continuously increasing, we will call it as uptrend. If the values are continuously decreasing, we will call it as a downtrend. And what is the seasonality? Seasonality means if the values either increase or decrease with the fixed time period, we will call it as they are seasonal values. So, what does the stationarity means? Stationarity means the mean is constant with respect to the time and variance is also constant with respect to the time. So, how can we check the stationarity of a series? So, for that, there are two ways. The first one is the visual way and the second one is by using the statistical test. So, you can use visual representation of a series by plotting that series with respect to the time. Otherwise, you can use the statistical test called ADF. So the ADF stands for Augmented Decay-Fuller Test. So for that, I have imported this ADFuller function from the stats models library. After that, I have defined a custom function which will take series as input. It will pass that series to the ADFuller function. This ADFuller function will return test statistic p-value and that p-value will be of our use. If that p-value written by that ADFuller function for the given series is less than 0.05, which means that given series is a stationary one. If that p-value is greater than or equal to 0.05, it means that it is not a stationary series. Now we have considered these two ways to check the stationarity of a series. So let's see in action. So as a first step, I have plotted that series with respect to the time and I have set its width and height to 15 as a width and 3 as a height, and on x-axis we have year and on y-axis we have the cells, and I have given the title to that chart, and I have also passed this series to our function check stationarity. Now what is the result that we have got? That this series in this series, there is no trend present. What is the trend? We have already seen that. You cannot see here any kind of uptrend or downtrend, and hence no trend is present in here. But it is seasonal. Why? Because at the every year end, the cells are at its peak, and that's the reason same pattern is repeating over and over years again, except for the year 2020, that is likely due to the COVID. Now, our ADF test has told that p-value is more than or equal to 0.05. Hence, the given series is not stationary. Can you see visually that is this series stationary? No, because the mean and variance are not constant with respect to the time, and hence this is not a stationary series. Now, how can we make this series stationary? By using differencing technique. So what is the differencing means? You have to take the current value of cells, you have to subtract it from previous month cells. Then you will get the differencing technique or differencing series values. So that can be done with the help of this diff function. And you have to store it into the DF1 data frame. So I have also dropped any NA values that I have come across, and I have visually seen that what is this series looks like after differencing, and also check its stationarity with the custom function that we have written using ADF test. So after seeing this chart, we can see that this series is stationary after first level of differencing. So we have differenced this series for one time, so it is first level of differencing. This series is stationary one, and that is also what our ADF test is telling us, that p-value is less than 0.05, that is this value, and hence the given series is stationary one. So you can see that the mean is constant and the variance is also constant, but there are some spikes in the variance, right? So to stabilize those spikes, to stabilize those variance, we'll have to take the log values. Now, which log values we will take? So we will provide the actual cells value that we have to the log function of the NumPy library, which will return us the logarithmic value of this actual cells. And we'll try to plot that logarithmic series over years, and we'll also check its stationarity by using our ADF test. So this is the graph, and what are the results given by this ADF test. So by seeing this graph, by looking at this graph, can you see, is it stationary? No, right? Mean and variance both are not constant, but the variance has been stabilized. Now this series is not a stationary one, that ADF test is also telling us. Now you can make it stationary by taking differencing. So you have to take the differencing of that logarithmic series that we have just plotted over here. Now once you take the differencing and once you try to see that particular logarithmic series over years along with the function check stationarity by for checking that ADF test, you can see that this series has become stationary after first level of differencing. So the logarithmic series that we have taken its differentiation, and that's why it is now has become stationary. So what is the next step after this is to check the seasonal decomposition of this logarithmic series. So how can we check the seasonal decomposition? So this seasonal decomposition will help us to break down that particular series into four components. The first component is the actual component that we have provided. Second one is the trend component. Third one is the seasonal component, and fourth one is the residual component. So for that I have imported this seasonal decompose function from this stats models library. After that, I have given the same logarithmic series, which is not a stationary one, to the seasonal decompose function. And let's try to see what the seasonal decomposition function has written us. So we have got these four charts. The first one is the log. So that is the actual values that we have provided, actual logarithmic values. So this is the same as that of that. Then there is a trend component, that is there any uptrend or downtrend. Then you can see that no trend is present in here. Then there comes the seasonal component. So this series is a seasonal over years. We have seen that earlier also. And the residue component, which means that the noise or the error that is present in the data. So the seasonal decomposition has helped us to break down the series in these two important components, trend and the seasonal. Now we have to choose time series model for the analysis purpose. Now, there are various time series models are available like AR, MA, ARMA, ARIMA, SARIMA, and SARIMAX. So, what does that stands for? AR means autoregressive. Autoregressive means it will predict or it will forecast the value, future values based on the past values of the same series. MA means moving average, means it will forecast the future values based on the past errors. ARMA is a combination of AR and MA, that is autoregressive moving average, means it will forecast based on the past values as well as the past errors. ARIMA is nothing but autoregressive integrated moving average. The integrated here stands for the number of times we have taken the differencing technique. We have used the differencing technique to make the series stationary. So that is the integrated part. And Sarima and Sarimax. stands for seasonal ARIMA and seasonal ARIMAX. So this seasonal ARIMA will forecast the future values based on the presence of the trend as well as the seasonality. So that's the S stands for seasonality. And this ARIMAX is the seasonal ARIMA with the exogenous variable. Means it will forecast based on the presence of the trend, seasonality, and also having an effect of an external factors. That X stands for exogenous variable. So these are various time series models available with us. So how can we choose the correct model? Before that, in each of the model, you can see that there is AR and MA common. So what is this AR and MA? And how can we find that? So it can be found with the help of ACF and PACF plots. So what are these plots? PACF stands for partial autocorrelation, ACF stands for autocorrelation. That is the correlation between these variables. And how the correlation will be identified? Based on the lags, right? We have only single variable called as a cells. So the given value with respect to its previous value. In this way, correlation will be found out. Now, we have to import this plot ACF and plot PACF function from the stats models library. And to check to find out the values of P and Q, you have to make use of this plot PACF function. You have to provide that logarithmic series which is not stationary to that functions, both of the functions, and then you will be able to see these two graphs. The first one is the partial autocorrelation graph which will help us to identify the value for P, and that p value is nothing but the autoregressive terms, and this autocorrelation graph will help us to identify the value for q, that is nothing but moving average terms. So let's try to understand these two graphs. So in this graph, this blue portion shaded area, it is nothing but insignificant area, and these vertical lines are the lags. So it starts from 0 up till 25. Okay. So we have to find out when the correlation has become 0. That will be the value for P, and same goes for the Q. So here if you check the value for P, we can take, so this is the 0th value, this is the first value, this is the second value. So after these two values, we can consider the correlation is 0. We can also consider the value for P as a 3, 4. Here it will be insignificant. Here it will be insignificant. Here also. But in this case it will be significant. So we can consider these two lags. So we can consider the value for P as 2. Then there comes autocorrelation to find out the value for Q. So again this blue shaded area, this one is the insignificant area. So whatever the lags which are inside this, we will not be considering. So here how many lags that you can see which are over that particular insignificant area. So there are two lags, like this one and this one. And hence we can say that the value for P and Q both will be 2. Now we have seen the value for P and Q by plotting these two graphs. Also we can check these values with the help of auto-arima function. Auto-arima function will give us the value for non-seasonal order along with the seasonal order. And for that I have imported this auto-arima function from PMD arima library, and we will be using Sarimax model. Why? Because this auto-arima will give us non-seasonal order along with the seasonal order, and that's what Sarimax expects. That's why I've imported Sarimax model or Sarimax function from the stats models library. Now, what you have to do is auto-arima result I have created this variable, and inside this auto-arima function I have given this logarithmic series that we have, which is not a stationary one, and the seasonality is there. So I have given seasonality, seasonal is equals to true, and m is equals to 12, means the number of seasonal periods that is we are trying to forecast. So here we are considering next 12 months, so I have given m as 12. So what this auto-arima will give, so this auto-arima function, it will help us to find out the optimal values of non-seasonal order and the seasonal order, that is the small PDQ values and the capital PDQ values along with this S. So S is nothing but the seasonal period. It will take some time to run this function, and once it is done, you have to use this summary function on top of it to see the results. So this autorima have used internally this Sarimax model, and it has given that this is the non-seasonal order and this one is the seasonal order. So this 2 stands for value for small p. This is the value for small d. This is the value of small q. This is the value of capital P. This is the value of capital D. And this is the value of capital Q. And this is the value of S, that is the seasonal period that we have. Now you can see that there are multiple statistical values that are written over here. What does that means is that AR means autoregressive, L1 means lag 1, AR is autoregressive, L2 means lag 2, MA means moving average, lag 1, lag 2. ARS.L12 means autoregressive seasonal part, it's lag 12. This is the MA seasonal part, lag number 12. These are the corresponding coefficients for that particular non-seasonal and seasonal lags, and these are the standard errors. And this Z value is calculated by dividing this coefficient with the standard error. And this is the p-value that we were checking for the stationarity. So this p-value is significant up till the lag 12. After that, it has become 0.372, which is almost greater than 0.05. So here it has become insignificant. So that's what we can conclude from this summary. So what we'll do is we'll provide these parameters that we have got from our autorima function to our Sarimax model. For that, we'll pass the logarithmic series that we have to the Sarimax function. We'll pass the non-seasonal order from the autorima and the seasonal order from the autorima itself, and we'll store it into this model Sarimax. Once it is done, we'll train our Sarimax model. Once the model is trained, we'll try to predict the values using predict function. Here I have given n forecast as 12. We can modify it if we want to forecast for the next 24 months or 36 months. That's why I have given this, created a variable. Now in this predict function, you have to pass from which record you want to predict the results. So for that I have given the length of our data frame, and also I have added that 12 months to that particular length, and 12 I have stored it into this variable, so which you can modify it also. So once you get this predicted values will look like this, but these values are too small. Our cells were very big. Why is this so? Because these values are present in the log. They are not the actual values. And hence, to go back to our original scale, we have to use the anti-log. So you have to use the exp function from the NumPy library. You will be able to see now predicted cells, and these are the actual values of the cells. Can you notice that in the December month we have the highest cells as compared to the other months, right? That was the pattern, and our Sarimax model has identified that pattern on its own, right? So this means these values are correct. It has predicted correctly our model. So now what we'll do is we'll try to create a new data frame which will hold these predicted values, and we'll try to plot the actual cells and the predicted cells that we have got from our Sarimax model into one frame. So here you can see that years are present and on x-axis and cells are there on y-axis. Now you can see these blue lines indicate these are actual cells, and this red line indicate this is the predicted cells. So our Sarimax model has identified this seasonal pattern. Accordingly, it has predicted the values. So that's all about the using Sarimax time series model for predicting the cells for an electronics and appliance store. In this way, you have to use this model. If you have found this video useful, please like this video, share it with your friends, and subscribe to our channel. Thank you.